Hello, everyone out there. I welcome you back again to our channel, Tutoring Made Easy. But I hope each and every one of you is doing great. Yes, the goal of this channel, Tutoring Made Easy, is to make math easy and enjoyable, and also to help as many people around the world as possible. Many people who are struggling with mathematics to be encouraged to take math and also to enjoy it while doing so. So if this is your first time coming in contact with our channel, please do us a favor by subscribing to the channel, liking this video, and sharing to as many people as possible. If you've been watching our videos, but I know we are busy, you don't have the appropriate time to do so, please do us a favor now and subscribe, like this video and share it. If you're already a subscriber, we thank you. We want to be grateful that you're already helping us to grow this channel. uh, Also, if you have any form of comment in terms of specific math topics that you want us to treat or do a video on, feel free and express that in the comment section below. But today we're going to be looking at the domain of a function, how to find a domain of a function, or how to find the range of a function. So first, let's look at the definition. The definition of what is a domain. We say a domain of a function. The domain of a function is the values. They are the values. Okay, they are the values. They are the domain of a function. They are the values of x. The values of x, and those values that make the function defined. They make the function defined. They make the function defined. They make the function defined. So any value of x that makes a function defined is the domain of the function. Is the domain of the function. So for example, let's take a look at something like this. You have a function ax to the power of 3. Who can tell us what type of function is this? We know for sure this is a polynomial function. But what type of polynomial function is this? It is a cubic, it's a cubic function. It's a cubic function. Why do we say it's a cubic function? Because the degree on the x is 3. So it's cubic. And it's a function because of this expression f of x. Yeah, that's what makes it what? A function. And it's a polynomial function or a cubic function. Now, the domain for this function, we can see is all numbers. This particular function can take on any value at all. It can take on any value at all. The x in there, x can be a negative number, or x can be a positive number. It doesn't matter. Or x can even be a rational number. X can be a fraction. It could be 2 over 3. Or x could be, sorry, I don't know why this is doing that. Or x could be negative 5 over 6. It could even be an irrational number where x could be square root of 7 over 2. It could be anything. So because of that, we can confidently say that this function f of x, which is, this function f of x, we can confidently say that this function, which is f of x, ax to the power of 3, it's all real numbers. All real numbers makes it what? Defined. And therefore, to write that, we'll say that the domain of this function is x, such that the x belongs to is a member of all real numbers. There is no exception. All other numbers, they fall under this particular function, and they all make the function defined. They make the function defined. Now, let's look at another situation where we have, let's say we have f of x, it's equal to 3x squared over x minus 1. We can see here that when x you can see, I don't know whether you can see that, but when x is 1 in the denominator, if x equal to 1 in the denominator, our function changes. Our function becomes f of x is equal to 3x squared divided by 1, because we said if x is equal to 1. So 1 minus 1 becomes 3x squared is equal to 0. And this denominator being equal to 0, this denominator being equal to 0 makes it undefined. It makes it undefined because of the 0. We cannot have a number divided by 0. So we can say that this function can take on any number, but it shouldn't take on the number x equal to 1. So the domain is equal to x, such that the domain is x, such that this x, the domain is x, such that this x is all real numbers. It can take on all real numbers except that it's not supposed to be equal to 1. It cannot be equal to, except x is equal to 1, sorry. Except x is equal to 1. Except x is equal to 1. Except someone can also write it this way. It's the same thing. Someone can write the domain is equal to x, such that the x belongs to all real numbers and x is not equal to 1. It's the same thing, except x is equal to 1 or x is not equal to 1. That is the only time the function will become undefined. I think we should try a couple. Let's look at a couple of numbers. Let's say that we have I'm trying to look for another one. Let's say we have f of x, it's equal to 3x squared minus 5 divided by x plus 1. Here, we can also see that the domain, we always check for the domain. If you have a function like that, you always check for what? The domain. You always check for the domain. So the domain, the denominator, not the domain, the denominator is x plus 1. All right. If x is equal to -1, it means that the x plus 1 will become, the x is -1 plus the 1, it becomes 0. We don't want that. If that happens, if x is equal to -1, sorry, if x becomes equal to -1, the denominator alone, all right, the denominator will become, we're gonna have f of x is equal to, sorry, I don't know why this thing is misbehaving. We're gonna have, sorry about that, we're gonna have f of -1, because x is equal to -1. It's going to be 3, sorry about that, it's going to be 3 into -1 squared minus 5 divided by -1 plus 1. And our denominator, we're going to get 3 to 1, -5. But the denominator becomes 0. And we don't want that. That makes it undefined. It makes this undefined. Okay. Therefore, we can say that this function, f of x, which is equal to 3x squared minus 5 divided by x plus 1, right? The domain is equal to x, such that the x belongs to all real numbers, but x cannot be equal to -1. X cannot be equal to -1. So that means the domain of this function can take on all values. It can take on all values. It can take on all values of x, except that x should not be equal to -1. This symbol is all values. All values. All values of x. That x cannot be equal to negative. X cannot be equal to -1. X cannot be equal to -1. I hope this helps. Now let's take a look at how to find the range. We're going to look at how to maybe look for the range of a function. Maybe how we can be able to look at the range, to find the range. Finding the range. Okay, let's find the range of a function. we've been able to look at the domain of a function. All right. That means domain is when the values of x that makes the function defined. That's the domain. But now we're going to look at the range of a function. So let's imagine that we have f of x to be equal to 3x squared minus 5 divided by x plus 1. We can make that f of x to be y. Okay? So first we can say we should let f of x be equal to y. Then it means that this f of x is y is equal to 3x squared minus 5 over x plus 1. The moment we do that, we want to make x the subject. We want to make, x stand alone. We want to make x stand alone. And to do that, how are we going to do that? Can somebody be able to help us? How are we going to be able to achieve that? Let's say our question again, instead of the squared, we rather have 3x. Yes, 3x minus 5. And then also, we're having 3x minus 5 here. So we made y to be equal to 3x minus 5 divided by x plus 1. We want x to stand alone. Now, we know that from a theory that we learned in the past, we said that if you have a over b being equal to c over d, we cross multiply. This multiplies this, we get a times d is equal to b times c. So we're going to cross multiply. We cross multiply. We cross multiply. We cross multiply. And if we are doing that, we're going to get y is going to multiply x plus 1. This is going to multiply this. And then whatever is here, which is 1 is going to multiply the 3x minus 5. And then we are going to get y into x plus 1 is equal to 3x minus 5. Now we are going to expand, right? We're going to expand this. So this is going to multiply this. We get yx plus this is going to multiply this. We're going to get y, which is equal to 3x minus 5. We group like terms together. So we are going to have this yx, because it has x, we want x to stand alone. So we have yx in here. This x also has to come here. So we're going to have minus 3x. Why? Because it crosses the sign. It crosses the equal to sign. So the sign in front of it, that is the positive 3x, will have to change to negative 3x. And once we're able to achieve that, what we have on the right-hand side left is negative 5. Sorry about that. What we have on the right-hand side is negative 5. And we're also going to bring this one here. The sign will change to negative y. Why? Because it also crossed the equal to sign. So this changes to negative. Now we can be able to factor. We can be able to factor x out. We want x to stand alone. And we're going to get y minus 3 is equal to negative 5 minus y. Now when we come here, we already have an x into y minus 3 is equal to negative 5 minus y. I hope you're following. Now we can find x alone because x will be equal to negative 5, and then we are going to divide both sides by what? Y minus 3 divided by y minus 3, and this cancels out. Once that happens, we get x standing alone being equal to negative 5 minus y over y minus 3. Now the range of a function is the values of y. Is the values of y that makes the function defined, that makes it defined. So the range of a function is just the same as the domain, but the domain is the values of x that makes the function defined. With the range is the values of y that makes the function defined. And in this case, if you look at it carefully or closely, if y is equal to 3, our denominator is going to be 3 minus 3, which is 0. We don't want that. Therefore, the range is equal to all y. Don't forget it's all y, not x. All y, such that the y, they belong to all real numbers, except that y cannot be equal to negative. It cannot be equal to 3. It cannot be equal to 3, because if y is equal to 3, the denominator will be undefined. So y cannot be equal to 3. And then that's where we leave it off here. We leave it off here. Please, if it's your first time joining our channel, or you have been watching our videos but you haven't had the time, I know you're having a busy life and you've not subscribed yet, please help us grow this channel so we can serve as many people as possible on this math journey of making math an easy subject and making it enjoyable while taking a class in mathematics. Let's help as many people around the world come in contact with a channel such as this. All right. If you have specific math topics that you want us to uh, treat or work on, we'll be more than happy to do a video on that. So please subscribe, like this video, and share. I'll come to you another time. Please take care and bye.